In this problem, we want to find the velocity function of the soccer ball in component form. Our first step will be to find a vector. We'll call it w, in the same direction as v, which will be our velocity vector. To do this, we need to know the distance between the two players. The problem statement mentions that one player runs a distance of 12 meters, then turns at a 90-degree angle and runs an additional 5 meters. Think of these distances as the legs of a right triangle. Let's draw a picture to represent the problem. We can find the distance between the players by using the Pythagorean theorem and solving for c. If we do this, we get that c equals 13 meters. Our next step is to find the magnitude of w. We already have the distance between the players and the angle the ball is kicked at, so we have 13 over the magnitude of w equals the cosine of 60 degrees. This means we can express the magnitude of w as 13 over the cosine of 60 degrees, which equals 26 meters per second. Now we'll find the vertical distance from the second player to the terminal point of w. We calculate this by multiplying the magnitude of w by the sine of 60 degrees. This gives us 13 times the square root of 3 meters. Now, we have w equals 12, 5, 13 times the square root of 3. And this vector has the same direction as v. Notice, though, that we found the magnitude of w to be 26, and we know the magnitude of v is 14 meters per second. This means we need to find a constant, k, so that the magnitude of w times k is equal to 14. Now we'll find a value for k. Recall that we said the magnitude of v is 14 meters per second. And we want a constant k so that k times the magnitude of w is equal to 14. So we'll set up our equation and solve for k. We know that k times the magnitude of w equals k times 26 meters. We want this value to be equal to 14, so we write k times 26 equals 14. Dividing both sides by 26 and simplifying, we get k equals 7 over 13. Now that we have our constant, we can find v by multiplying k by w. Recall that w equals the vector 12, 5, 13 times the square root of 3. This gives us 7 over 13 times the vector 12, 5, 13 times the square root of 3. We know that multiplying a vector by a constant means we multiply each component by that constant. This gives us the vector 84 over 13, 35 over 13, 7 times the square root of 3. To check to make sure we have the correct vector, we can find the magnitude of v, which should be 14. And we can see that the magnitude of v is indeed 14.